Alright, welcome to Colossus Mathematics class. Don't forget to subscribe, like and share this video. In today's class, we are going to be talking about continuity. If you have checked my previous video, you will have watched my series on limits. So we want to talk about continuity now. When do we say a function is continuous? A function is said to be continuous if it satisfies these three conditions. A function is said to be continuous if it satisfies these three conditions. Number one condition. The number one condition is that the limit of f of x, as s approaches a, should exist. I get what I'm saying now. So that means the limit of that function must exist. Number two is that the function must be defined. Number two, f of a must be defined, or you can say f of a must exist. Are you seeing that now? F of a must exist. So that's the second thing. F of a must exist. And then the third one now. The third key is that your f of a must be equal to the limit that you got. Are you seeing that now? So if these three conditions are satisfied, then you say that the function f is continuous at x equals to a. You say the function is continuous at x equal to a. Are you seeing that now? So that is what we mean by that. Alright, so now let's see example. Now before I look at example, number one thing is you must know that every polynomial functions are continuous. So any function that is like not having denominator will always be continuous. Are you seeing that now? Any function that is not having denominator will always be continuous. So let's take, for instance, if I have an example like this. So check if f of x is f of x given by 3x. I think that 3x minus 7 is continuous at, you want to check if this function is continuous at x equal to 7. Are you seeing that now? You want to check if the function is continuous. How will you do that? This is actually very simple. So the first thing you have to check is the limit. So you will say the limit. This is your a now. Are you seeing that now? So as x is approaching a, now instead of writing a now, I will now say 7. Are you seeing that now? So that is what we are trying to say with those definitions. 7 of 3x. This is your f of x now. Are you seeing that now? Minus 7. Are you seeing that now? So that is what you want to do. You can see that it has become like this now. Are you seeing it now? So that is what we are doing. This is example 1. Are you seeing that now? So I will not say this is equal to. I'm sure if you want to do this limit, you just put this 7 directly anywhere you see x. Are you seeing that now? So this will now become limit. There will not be a limit there again because you want to put a value now. Are you seeing that now? So that will just give us 3 into 7. Are you seeing that now? Then minus 7. I just changed this x to become 7 now. Are you seeing that now? So now 3 times 7 is 21. Are you seeing that now? 21 minus 7 will give us 14. Are you seeing that now? So that means the limit as 3x plus 7 is approaching 7 is equal to 14. Are you seeing that now? So now the second condition, this is the first condition. Are you seeing that? This is the first condition. The second condition now. The second condition is f of a must be defined. Are you seeing that now? Don't forget that f of x is equal to is equal to 3x minus 7. So what will be f of a? F of a, which is now? 7. Are you seeing that now? F of a, so that's f of 7. You want to check f of 7. F of 7 will be 3 into into 7 minus 7. Are you seeing that now? So 3 into 7 minus 7, 3 times 7, 21 minus 7, and that gives us what? 14. Are you seeing that now? So clearly, you can see clearly from here, that our f of a is equal to what? 14. Are you seeing that? And our L here, this is our L. Are you seeing that now? Our L here is also equal to what? Is also equal to 14. So L is also equal to what? 14. So you can see clearly now that what? That f of a, are you seeing that now? You can see clearly that f of a is equal to what? Is equal to L. Are you seeing that? Therefore, the function, you just conclude that the function, what? The function, what's the function? 3x minus 7 is continuous. Are you seeing that now? Is continuous at x equal to what? Equal to 7. Do you see that now? So that is the conclusion for that value. So check it again, check it, and you see that it is actually very simple. All right, so now I will go to another example now. Are you seeing that now? So I will go to another example so that you can be sure that you understand what I am doing. Are you seeing that now? So let's see another example in form of fraction. It is those one of fraction that you may be doubting if they will be continuous or not. So I want to give you another key. So let's say we have limit as, not limit, sorry. So you want to check. So example 2, let's change this pen here now. So let's use this color. So example 2. So you want to check if the function h of x given by, so our h of x is given by x raised to power 3 plus what? Let me write down my x very well so that there will be no error. So you have x raised to power 3 plus 24, x raised to power 3 plus 24 all over x minus 2. You want to check if it is continuous at x equal to what? Equal to 1. Now, are you seeing this now? If you look at this question, it will be continuous. Why do I say it will be continuous? The only time this function will not be continuous is at when x is equal to 2. So if you see this question in exam, you just look at the denominator. Are you seeing that now? If you look at the denominator, if you put 2 in this denominator now, it will become 0. So that means this function will be continuous at any other number except at what? At x equal to 2. Because if you put 2 in this x, you will get, if you put 2 here now, are you seeing that now? You will get 2 minus 2, which will now become 0. So that will be what? That's why it will be discontinuous. Are you seeing that now? So now let us now prove that it is continuous. How do we prove that it is continuous? For us to prove that it is continuous, what we are going to do is very simple. So just like we did the first time, so we are going to do the limit. So the limit at x equal to, as x approaches what now? 1. I think that our a here is 1 now. So limit as x approaches 1 of what? Of x raised to power 3 plus 24 all over what? X minus 2. Are you seeing that now? So this will now give us, since if I put 1, I will not get 0, so I'll put 1 directly. So that will give us 1 raised to power 3 plus 1 raised to power 3 plus what? 1 raised to power 3 plus 24. Are you seeing that now? Over what? 1 minus 2. So that will give us what? 1, because 1 raised to power 3 is 1, plus what? 24 all over what? Minus 1. And that will give us what? 25 over minus 1. and our answer will be what? Minus 25. Are you seeing that now? So that is our answer for the first one. Then for the second part now, which is the f of a, are you seeing that now? You want to check that the f of a will exist. So here you want to check h of a must exist. Are you seeing that h of a must exist? So how will you do that? Your a is what? Is 1. So you want to check for what? H of 1. Don't forget your h of x. Our h of x is what? X raised to power 3 plus 24 over what? X minus 2. Are you seeing that now? So our h of a now, h of a, which is what? 1, will now be what? Anywhere I see x, I'll put 1. So that will be 1 raised to power 3 plus 24. Are you seeing that now? All over what? 1 minus 2. That will also give us 1 plus 1 plus, so 1 plus 24 over minus 1. Are you seeing that now? So that will also give us 25 over minus 1. That means our h of 1 is also equal to what? Minus 25. And you can see clearly, are you seeing that now? You can see clearly that what's it called? Our h of a is what? Is 25. Our L, the answer for the limit we also got, is also what? 25. Are you seeing that now? So that means you can see from here that what? That h of a is equal to what? L. That is minus 25 is equal to minus 25. So that means this function is what? Is continuous at x equals to 1. Are you seeing that now? So you see that the function is what? Is continuous at x equals to 1. So assignment, try this as assignment. Check if the function are continuous. Number 1, f of x equals to 2x plus 5 at x equal to minus 1. Check if this function is continuous. Number 2, check if this function is continuous. H of x is equals to x squared minus 1 over x minus 1 at x equal to 1. Are you seeing that now? So check if these functions are continuous at this interval. So thank you very much for watching. Don't forget to subscribe, and if peradventure you need a private personalized class online, feel free to send a message to my WhatsApp number 0705260 this is 526092 and 33. Let me write that again here. 07052. Let me write that here. I don't know, my pen do not want me to write my phone number for you. Alright, but I want to help you with online classes, so I need to drop my number for you. So for my number, the number is 070526092 and 33. So that is my WhatsApp number. Feel free to send a DM to me and I will discuss a class plan with you. Alright, so don't forget to subscribe, like and share. These are the 3 conditions that must be satisfied for a function to be continuous. Don't forget that. Alright, so I will see you in the next class. Thank you very much and do have a great day. Alright.